Welcome everyone behind the screen to follow Terkko Health X Showcase 2021. 6 weeks of intensive workshopping crystallizing the business idea and practicing the pitches culminates into this evening when finalists will present their businesses to the judges who will then decide the winners of Terkko Health X Pre-Accelerator this year. You can almost feel the excitement in the air, at least here, even if it's via video connection. My name is Sofia Leinonen and I will be hosting today's event. And I'm representing Helsinki Think Company, which is the co-organizer of this year's Terkko Health X. And without further ado, I welcome my colleague Lina Lauconian, who is the project lead of the program, on the stage. Go ahead, Lina.
So, first of all, thank you all who are watching the showcase tonight. I'm Lina Lauconian, the project lead of Terkko Health X this year and also the representative of Terkko Health Hub, one of the co-organizers of Terkko Health X. So, Terkko Health Hub is the startup hub here in Helsinki, which is dedicated to health tech and life sciences startups. One of the Terkko's most important aims is to help health and life sciences startups to thrive, and due to this, me and our team are so thrilled to follow tonight's pitches. At this point, I'd like to thank our lovely team who has been organizing this program. It has been a pleasure to work with all you, and you've done just a great job even tonight with all this technical stuff. You've been so helpful. Additionally, I'd like to thank all our partners, University of Helsinki, Helsinki University Hospital, High Life, Amazing, IVS, and also Sitra. Another thank you goes to all the mentors who have been sharing tech knowledge for all our teams in our weekly workshops. All your contribution and help has been irreplaceable, and thank you for making all this possible. And last, but definitely no least, I'd like to thank all our participating teams. This is the day that we have all been waiting, and it has been such a pleasure to follow how all you have grown during our program. So, thank you. This was all from me, and please enjoy tonight.
So we will start the pitches very soon, and each team has 3 minutes to present and then 10 minutes to receive questions from the judges. And I will keep track of the time and let you know when the 3 minutes is up. And after all the teams have presented their work, we will have a break at about 7 p.m. And during this time, the judges will discuss and carefully evaluate the team's pitches. And we will return from the break 8:15 and get to hear the top 3 of this year's Terkko Health X Pre-Accelerator. And finally, the winner. And to keep our teams behind the screen motivated, I next present our prizes. The third ranked team will receive 6 months of Terkko membership for free. And the team that comes second will get 1 startup ticket to next week's Slush event, and additionally 6 months of free Terkko membership. And last but not definitely least, the winner of Terkko Health X will be granted 2,500 euros, 2 Slush startup tickets, and of course 6 months of free Terkko membership. And for all the participating teams, we are giving a 50% discount for 6 months of Terkko membership and 5,000 Amazon Web Services credits. Pretty exciting. And the 6 teams presenting their ideas today will be evaluated by our expert judge panel. So let's take a look at our impressive judges consisting of 4 experts within the field. First, we have Marko Berg, who is Deputy Chief Investment Officer in the University of Helsinki. Marko, can you tell us what are you looking for, especially in today's pitches?
Thanks, and thanks that I have a possibility to be here. I'm very eager to see all the new cases, and I just want to see the new cases and the new innovations, and of course it's always interesting to see and meet new people. So the teams are very important, as everybody always says.
Definitely. Next in the judge panel, we have Virpi Muhonen, who is the CEO and co-founder of Askel Healthcare. Virpi, what are your expectations for tonight?
Yes, hi there. Great to be here. So I'm a big fan of academic entrepreneurship. So I'm really looking for like deep science driven teams which has huge kind of visions for the future. And I'm sure I will see many of those in this evening. So really looking forward to hearing your pitches. Good luck to everybody.
Thank you, Virpi. We are big fans of academic entrepreneurship as well. One of the panelists is also Johannes Olqvist, who introduced himself and Sitra already before. Johannes, are you excited about today?
Yeah, of course. I'm just looking to learn. I'm looking to get new ideas, and of course, I'm looking to find something that has to do with my projects, but I won't let that cloud my judgment.
Thank you. And last but not least, we have Pinja Krug, who works as a patient journey and solutions lead at Novartis Finland. Finland, as a medical company representative, what are the things you're going to pay special attention to today?
So yeah, hi everyone, I'm Pinja Krug from Novartis Finland, and behind this great title of being a patient journey and solutions lead, I have a background of, I've been doing healthcare service design for about 6 years. So I think that's the perspective I'm very interested in, kind of the problem definition and collecting insights and how to find the right solution. Great to be here.
So finally, it's time to get into the pitches that we've all been looking forward today. I hope our teams are ready, and I wish the best of luck to all of you. You worked hard for this evening, and now it's your time to shine. We will be taking time, and I'll announce when the time is up. And after that, I will give the floor to our judges. And first to present their idea is Autonomous Spark. And Autonomous Spark focuses on reducing healthcare associated infection through autonomous dispenser technology and laboratory testing. So go ahead, Autonomous Spark, whenever you're ready.
I'm Mark from Autonomous Spark, and I would like to present our business idea to you. Hundreds of thousands of patients each year are affected by a healthcare associated infection in the, in the world. And, sorry, this is a bit of a technical fun. Don't worry. Okay. All right. Problem with the healthcare story is healthcare infections, hospital-acquired infections. 7 to 10% of patients suffer from it. Everybody goes to hospital. 30% of patients in intensive care get called out by it. 37,000 people die in the European Union, costing 7 billion euros a year. 99,000 people die in the US, costing $6.5 billion a year. Autonomous Spark has developed a autonomous dispenser device using NFC technology that can help companies understand the where, when, and how dispensers are used. Our process that we use to go through is we set up the device, and we then use the device is used by customers, and then the data that the device generates is analyzed, and then the customers can adjust their processes in accordance with that data that they've gathered. And after all, we then go through a process of Kaizen, which is gradual and improvement for the customer. Value we want to bring, we want to save lives. We want to add value to the overall health of patients and staff. We want to provide objective feedback on how well the existing hand hygiene measures are being followed. We want to provide intelligent information of hand hygiene practices to the health of the healthcare staff. We want to improve efficiencies in healthcare providers, and we want to reduce the costs to institutions and medical aids. And potentially saving lots of money. Our strategy is to develop a prototype, which we've now generated. We've invented it. It's now going to be tested in a pharmaceutical company in South Africa as a prototype, and then also doing proof of concept tests within various hospitals inside Finland. After we've done a proof of concept, we will go through the regulation component and the IPR side of things as well. And then once you've done that, we will roll it out to the 3,000 hospitals in the Finland, Nordic countries, Germany, and South Africa. And once we've gone through that, we will then begin to address the 164,500 hospitals in the world, and also opening it up to the food industry as well. So once we've gone through that, our business model that we're aiming at, we're talking about hardware sales, SaaS revenues, and services. And we don't want to get too big too quick. So we said our first year, we're going to have 4 customers. Second year, we'll have 8 customers. And the third year, we'll have another 11 customers.
Thank you, Mark.
Up to you. That's it. Thank you.
Thank you, Autonomous Spark, for your insightful pitch. And now it's time to hear from our judge panel. Marco, would you like to start with your comments?
Anyway, so you, if I understood correctly, so it's a kind of device that links the person who is using the dispenser. So to what kind of a dispenser this? Is it all kind of a dispenser, or what kind of?
The dispenser can be used for soap. I mean, soap is the primary one because the United Nations have got the idea of hand washing being a thing that you should be doing. So
yeah.
The dispenser can be used for soap, but it can also be used for any other, let's say, sterilization or disinfectant solution, whichever. It's up to you.
How much kind of a work does it need to on a dispenser side? If I understood correctly, the kind of a tag that the healthcare personnel is having, that will be rather small, I guess. But what about the dispensers? What do you need to do about them?
Basically, it uses NFC or near field communication technology. So let's say you have a name tag with the NFC tag on it. You would touch it close to the dispenser, and the dispenser would deliver its product. Okay,
so it's kind of a tag for the healthcare personnel and tag to the dispenser.
Correct.
Okay.
Correct.
Yeah. Sounds quite easy. Thanks.
Sure. Thank you.
Thank you, Marco. Next, we'll move on to Virpi.
Yes, hi there. Now I can have the video because I had some technical problems beforehand, so I didn't have the video on. So hi, everyone. So yeah, there are many questions in my mind, but first I would like to ask, what is your kind of IP position? What's really unique and protected in your solution?
The device itself and the NFC technology, that has got its own IPR component associated with it. Because the design of the, let's say, the antenna for the device and its integration to the dispenser itself, that is an aspect of IPR that we will be patenting. We will be going through the patenting, yes, and also going through the regulation aspect of it as well.
Okay, so it's not protected yet, but you have plans to how to protect it.
It's in process, yes.
Okay. Okay, and one extra question before we move to the next panelist is that you didn't have time to really go through the team, so I would like to hear more about the team.
Yes, certainly. The team is made up of myself, an entrepreneur with 30 years experience in the IT industry, linked with Joanne, who has more than 20 years experience in the software and the telecoms industry. And then the other co-founder is Andy, who has more than 30 years experience as a microbiologist.
Okay.
And the
sounds like a good team.
Yeah, 3 of us together, we're actually all friends. We've all been friends for a long time. So we believe we're a strong team.
Sounds really good. Thank you.
Thank you.
Johannes, would you like to comment next?
Yeah, sure. Yeah, it's a real problem that you are solving. I'm just interested in like what the business model was a bit, let's say, it didn't go into details, so I'm a bit unclear like what the business model would be, but maybe about the market, or like what's the competition, and what are the solutions now, and what does this improve in relation to the current state?
Thank you for the question. Andy might be a better one to answer this question with his background on the medical side.
Yes. Well, the core idea behind Autonomous Spark is one of supportive service to the healthcare system. And by utilizing autonomous technologies to capture and record existing sanitation protocols into real-time data, which can then be correlated into improving current systems. And we're going to try and do this without much disruption at minimal cost. So there isn't anything like this at the moment. There are automatic dispensers out there, but we're trying to correlate data, real-time data of the usage of these devices, and thereby supporting the existing protocols are in place in healthcare systems. And we're also looking to do it in the food industries as well, where you have a lot less technical expertise and where you've got a lot more of these places that need regular screening as far as sanitization and washing of hands is concerned. So our business model is mostly on Joanne's side of things. My expertise will come to the microbiology side of it. I also have a 3-year food tech, so hence why the food industry is something that I think we need to look at as well. But initially, I'm saying I think that the hospitals and the healthcare providers would benefit from utilizing such a device.
Thanks.
Thank you. Then final comments and questions from Pinja.
Yes, I can't put my video on. No, yeah. Somehow it doesn't work. Thank you for the presentation. And I really liked how you shared at the beginning some data about the problem. It seems like I didn't understand that it's such a big issue. My question is kind of related to, like, do you know how big problem like is the hand hygiene causing X% of the problem, or are there other aspects to that cause it? And then also, are you expecting some kind of behavioral change with the, for example, healthcare staff with this, or kind of understanding the problem definition a bit more?
Joanne, would you like to answer that, Lotte?
So just to take the behavioral part of it, what we've looked at is the fact that people, if you look at the situation now, lots of people, when they go into hospital, etc., there's sanitizers there, and you have to actually, it's your option whether you can use it or not. And what we're looking at with this particular product and way of working in service is to drive the behavior behind it with the psychology of people. So as people start using it more and they see other people using it, and then you also look at the impact of things. So what we would like to do is actually have the understanding of what percentage of patients have hospital-acquired infections or healthcare-associated infections, and how many have community-sourced infections, have that as a sample data. Then we go through the process, and then we see what is the effect after a certain time period when people have been using the solution. So twofold: one, that you could actually show people the impact, and the other part is the psychology when you see people using it and working with it, and then it drives other people to adopt that as well.
Yeah, great, thanks.
Perfect. And just on that, the first part of your question was about what are the linkages to actually how much of the health-acquired infections are creating the issue. We've actually looked at some research papers that have already been done and particularly in Finland as well. And we've seen the impact of health hygiene related to actually people washing to infections happening. But through our process, we would like to actually validate it and get more data on this to be able to distribute more information in this regard.
Great, thank you.
Thank you for all the good questions and answers. So next we will hear from Biomedical Spectroscopy Lab. And the team has developed a novel optical sensor called JEDI for real-time assessment of connective tissue quality during arthroscopic surgery. And JEDI provides quantitative tissue diagnostics as opposed to the traditional diagnostic approach that is based on the subjective visual assessment of superficial tissue properties. That sounds interesting. So go ahead, Biomedical Spectroscopy Lab, whenever you're ready.
Okay, can you hear me?
Yes.
Okay. All right, good evening. My name is Isaac Afara, and I'm from the Biomedical Spectroscopy Lab. Now, we all know that medicine is supposed to be an exact science, but have you ever wondered how much guesswork is involved in the average orthopedic surgery? Now, imagine a situation where you injure your knee to a point where surgery is needed. Now, either you're a pro athlete or a regular person, the surgeon will operate on you arthroscopically. During this procedure, diagnostic decisions are based on visual evaluation and manual probing of the tissue using a metallic hook. And the problem with this approach is that it's highly subjective and poorly reproducible. And this results in poor clinical outcome. So to address this issue, we developed JEDI, a joint evaluation and diagnostic tool. JEDI is a smart optical sensor that replaces the traditional arthroscopic hook. JEDI combines near-infrared spectroscopy and artificial intelligence for rapid and quantitative evaluation of tissue integrity in real time. Now, JEDI is able to differentiate between healthy and diseased tissue, and there are no device like JEDI in clinical practice as we speak. JEDI is backed by more than 25 research publications spanning over a decade of research. Now, to highlight the importance of our innovation, osteoarthritis, which is the main joint pathology, affects more than 70 million patients in the EU and US alone, and results in more than 10 million surgeries per year. So we believe that integration of JEDI into the clinical workflow will result in better surgical outcomes, less revision surgeries, and improved quality of life. Based on preliminary market analysis, we actually discovered that the arthroscopy devices market is both fragmented and consolidated, and consists of 6 main players. However, there are significant opportunities in the market. For example, the market has been estimated to double in less than a decade, but there are no similar devices like JEDI in the market. So this presents a unique or fair advantage for us. So our goal is to enter into the EU market by 2030. Now, in doing this, our strategy is captured within these 4 key points. Now, we have already commenced preliminary regulatory activities. We have defined our revenue model, our customer base, and key metrics. Currently, we are undergoing preclinical tests of JEDI, and the results are quite encouraging. We hope to move into clinical trials soon, and in following with this timeline, we hope to be in the EU market within 10 years. Now, the team behind JEDI is a team of researchers with strong collaboration with clinicians, mostly orthopedic surgeons in Finland and overseas. And our core aim is to deliver evidence-based diagnostics in orthopedic surgery. Thank you.
Thank you, Isaac, for the pitch. So let's move on to the comments and questions from our judges. Virpi, would you like to start this time?
Yes, absolutely. Thank you. Very interesting presentation. So once again, many questions in my mind, but if we start from the first one, I was just thinking that what kind of preclinical data you already have? Have you been able to test the device, and how would you describe how it functions, and what kind of further development you might be facing in the future?
Okay, so I'll start by defining or describing how it functions. So it's based on near-infrared spectroscopy. So it's basically a biophotonics technique. So you put light into the tissue, there's interaction with the tissue, and then you get the reflectance back, basically response back. And based on specific absorption and scattering, we can detect what's happening at different spectral ranges. And using that information combined with machine learning, we can determine if the tissue is healthy or if it's damaged. Concerning the preclinical data, we've actually done measurement on 26 cadaver joints, and we looked at different properties of connective tissues. For example, cartilage, we looked at the biomechanical properties, we looked at the thickness, the polyglycan content, collagen integrity, all of those different parameters. And part of the results have been published already, and they were quite encouraging.
Excellent.
So meaning that the
really
surgeon can actually detect if the tissue is healthy or if it's degenerated or if it's anything in between.
So do you follow like the typical OA kind of levels of OA, or what is your kind of idea that what is healthy and what is damaged? There's so many variations in that area. Yes. So how do you classify it, and how does that kind of based on maybe the treatment decisions and this kind of things? So how well do you kind of qualify the tissue?
Yeah, that's a very good question. So initially we based our diagnostics on things like, for example, ORC scoring and Mankin scoring, and also ICRS scoring. However, we realized that ICRS scoring is actually slightly flawed because the surgeon is evaluating the tissue visually, and it's based on depth of lesion. It's very difficult for you to perceive depth on a 2D plane. So our diagnostics is actually based on the biomechanical properties and a few other parameters that are, these are quantitative and they are objective, not subjective. So we are trying to take away the subjectivity from the whole diagnostics.
Yes, thank you. Very good answer.
Thanks.
Johannes, would you like to continue?
Yeah, sure. I also have a lot of questions, but maybe I'm interested in the market and the business model that you went. It was quite brief overview of the competition in a way, and as I understood that there's no one is kind of solving the problem that you are. But let's say that you would get in Finland, you would get let's say 100,000 patients using this, or 100,000 patients would get benefit from this. What would be the business case for hospitals or the healthcare providers? Like, what does it actually save money to use this?
So Iman, do you want to take that?
Hi. Yes, I believe the direct compensation that would have based on this technology is for these insurance companies, right? Because what they do technically is to reduce the number of surgeries that they initially covered with their insurance package. So that's what we are targeting. And most of these economic impact comes from this. On the other hand, if the patient has been covered, let's say, by a public insurance, the other beneficiary of this technology would be the government providing this public insurance as well, which subsequently leads to reduced number of surgeries on the hospitals, which on the other hand helps the government or the hospital itself because of the allocation of its, let's say, employees, nurses, surgeons, and so on and so forth.
Yeah, thank you. Thank you. That was actually interesting that the insurance companies would be the customer. Yeah, thank you. I don't have any better questions, so I think the other guys will have better questions than I have.
No worries.
Thank you, Johan. Next, Pinja.
Yeah. Hey, thanks. Great pitch. Well, my question is about orthopedic surgeons. Have you tested this concept somehow with them already, or have you had them involved in when developing this somehow?
Yes, actually, we didn't have a slide that actually shows the traditional arthroscopic hook. So during the design of our tool, we actually had several consultations with orthopedic surgeons, and we designed it to look exactly like the existing arthroscopic hook, only that our system is smart. And the idea behind this is that we wanted to limit the learning curve for them on how to use the tool. So because they're already used to the traditional hook, they only just need to learn how to place this tool. That's the difference. But there's been a lot of interaction between us and orthopedic surgeons. And regarding the use, all of the preclinical tests has actually been done by orthopedic surgeons. And we've actually done in vivo tests on animals, and this has been done by a vet orthopedic surgeon as well. So all of our preclinical tests has been done by orthopedic surgeons.
Great, thanks.
Thanks.
I'm probably the next one. So,
Yes, go ahead, Marco.
It sounds weird that the current product has not any intelligence in it. So is it actually so that people all over the world are using just like a hand feel?
Yes, absolutely. In a lot of cases, the surgeon would look at the tissue superficially, and they would decide if there's something wrong with the tissue or not. But one of the key problems that happens with diagnosis of cartilage defects is that the early stages, you actually don't see any visual changes. Generally, this would happen when you have moderate to advanced degeneration, and at that point, usually it may be very, very difficult to treat. So this is where a tool that can go beyond the visual space, this is where a tool like that will become really important. But currently, there's no smart tool that's been used in orthopedics, in joint surgery.
Is it any way possible to show that how much change would have happened if they have used your kind of a product? So how many surgeries wouldn't have been made and so forth? Is it possible to backtrack anyway?
Yes, we actually hope to do that. This will take some years, because it will take years for us to know how many patients that have been treated with our tool have come back. So, but we believe that there will be a massive change, because now one of the points with joint surgery or cartilage surgery is that depending on the size of the injury, the surgeon can decide to leave the injury and expect it to heal, or he can decide to repair the joints. But one of the issues is that he doesn't know how far the injury has spread from that local point. So our tool will allow the surgeon to see the spread of the injury, even though tissues around the injury seem to be normal, but they may be degenerated. So our tool will allow him to see the spread of the injury, and then he can have a more informed decision whether to treat or not to treat.
Just a quick comment still. Have you any like a commercial traction? So is there still like a is this have you tried to sell it, or any feedback about pricing and interest in buying and so forth?
No, actually we've been more research focused, and we've not actually looked at the business side until recently. So this is why we were involved in this preaccelerator program.
Good. Yeah, I think it's good to start.
Yes.
Sooner rather than later.
Yeah. Thank you.
Yeah.
So thank you. Unfortunately, the time is up and we have to move on to the next team. So the third team to present their business is Food Waste to Burn Patch. And Food Waste to Burn Patch is tackling the issue of food waste, which is a vast problem in terms of land, air, and water pollution. And the team utilizes food waste to make hydrogel polymer bandages at affordable prices. And the team is creating value for patients by providing cheap, high-end products. Food Waste to Burn Patch, the stage is yours.
Hi, my name is Sunil, and I am here with the team Food Waste to Bandage. It is a saying that excess of everything is bad. So is the excess of food produced at industrial level that results in all kinds of pollution and greenhouse emissions. On the other hand, overnutrition related diabetes and foot ulcers are on the rise in the modern times. So we combine these two problems into our cutting edge solution. We call it MCell, MCell Green Bandage. So how we do it? The process starts by breaking down of carbohydrates in the food, which are fed to microorganisms during fermentation. In 3 to 7 days, material is produced, which is then decellularized, decolorized, and finally sterilized. Why this material? An ideal bandage should have certain criteria. This material have all those ideal characteristics and more. It is non-toxic, non-pyrogenic, biocompatible, helps with the transfer of medicine into the wound, high mechanical strength, easy and painless release from the wound. We intend to generate revenue via selling carbon credits, licensing, selling bandages, selling organic acids and related materials, and also the bulk material. The market size for the advanced bandage is around $20 billion. Our customers would be hospitals, clinics, trauma centers, research institutes, and other manufacturers. Okay, so compared to our comparing us to our competitors, for example, Excel, Epicel, and Genflex, our costs are very low due to the use of food waste. For example, Epicel costs around $18 per centimeter square, while our bandage will cost around $0.02 per centimeter square. Similarly, the UPM Fibdex, which is produced from the Berg pulp, it follows a very highly polluting and energy intensive process. While the processing of pulp to nanocellulose is also quite energy intensive. Compared to that, our fibers are 100 times smaller than the plant fiber in their native form. So they are at nanoscale. Who are we and what is the team? This is me, Sunil. I'm a material scientist. We have Shwete, who is a business expert. Marika is a medical student, and Anthony, he is as advisor with us in microbiology. Thank you. The floor is open for questions.
Interesting solution. Thank you, Sunil. So this time we'll start with Johannes.
Yeah, thank you. Thank you. I'm interested in the actual details about your solution that you said. I don't know the exact numbers, what you said, I don't remember anymore, but it seemed like it would be 100 times cheaper than one of those alternatives. Like how could that be? And then the second question is what are the drawbacks of your solution? There must be some.
Okay, so how is it so cheap? Because food waste is basically waste. So that's why it's so cheap. Other producers in the same field who are producing the same material, they are using basically very high cost feedstocks, that what we call them, for fermentation. So that increases the cost of it. And actually this material does exist. So what we are doing is by the design of our cell factory and by the design of feedstock that it can use, we are reducing the cost that low. And apart from that, some other materials that are used in the same industry are very expensive synthetic materials. That's why also the cost is so expensive. The other question was like, what are the drawbacks? Well, if we can like, maybe we can go back in the slide, Yanni. I just wanted to show something. Back to the ideal bandage. Yeah, here. Okay, so here are some of the properties that an ideal bandage should have, but none of the bandages on the market will have all these properties. But I can tell you that this material that we have right now, you pick one property and it have it out of here and more, basically transparency. And so I mean, I haven't heard a bandage that is transparent, that like you can observe a big wound through. So yeah, I mean, there is very little drawbacks, if you might say. Actually, it's solving much of the like issue of having an ideal bandage.
Okay, thank you. Sounds great. I think I also have questions about the clinical process, but I think Virpi will ask those. So
yeah,
so I will let her ask.
Okay, yeah.
Virpi, would you like to answer them right away?
Yeah, that was one of my questions, was that how about the regulatory path? How you see it? How do you bring this to the patient actually, and how far away are you in it? And the second question, I hate people who ask multiple questions, so sorry, I'm doing it myself now. So that's the regulation and then the revenues, because you showed a mixed revenue model. This is kind of good because you have multiple options. But how about like prioritization? Where do you start and why do you start from there?
Yeah. So the first question was regulatory.
Yes.
So one thing that we might be relying on is like existing data. So back in 1990s, I guess, the Johnson & Johnson tried to like work with the same material, but because of no technology for high production, a very high production cost and like low throughput, they didn't go ahead with the commercialization of these similar kind of products. But the thing is that there is tons of data published already. So I think it wouldn't be a big issue, but what our strategy is to combine our research with some university, some test bed, and go ahead and check our product for clinicals at a small scale. And then from there, we want to spend more money on going for proper regulations for reaching the customers. Okay, the second question you asked is, could you?
The prioritization, yeah,
prioritization
absolutely.
Of
so the
revenue,
yes, indeed.
So one of the idea is like the first thing that we might want to do, it would be like if we produce the material and make a brand of ourselves, a bandage, and then we sell it. So that would be like our priority, to establish ourselves. And then we can go for the white label products. And of course, there are side stream products. We have to sell them also.
Okay, thank you.
Thank you. Pinja, would you like to comment next?
Yeah, thank you. Really interesting solution. Well, maybe I have like hard time understanding like how can it be so cheap? Kind of the same question that was already asked, but to kind of go deeper into that, how do you already like, are you assuming that it's almost free to get the food waste, or are you already partnering with someone, or have you tested that it's any type of food waste will do, or are there certain criteria it needs to?
Okay, there are so many questions in there. I would try to do my best to answer. So not like, you cannot say like fish waste, there is proteins, we are looking for carbohydrates. So like maybe whey liquid that have like, for example, lactose in it, we can go for starch-based waste, cellulose-based waste. So as I said in my speech, carbohydrates. Okay, second thing is that like how like getting the food free. For example, it might cost us just the transportation of it. For example, supermarkets place tons of fruit back in their dump. So there are like companies which pick it up, and they are like, I guess in this, for example, in Finland, in Espoo, there is this plant where they are composting all the bio-waste. So we can divert that transportation of the waste to our facilities once we have our facilities. Apart from that, 45% of, let's say, potatoes on a farm are wasted. They are just buried back into the ground. So they would like to sell that to us, of course, at lower cost because it's not for food. The third thing was like, are you also concerned about production costs?
Yeah.
Yeah. So the cell factory that we have designed is a modular design. So it's every module sits on top of another. It's like 1-inch module. And the processing system would be similar to something like a beer mash producing vats. And we just need a pumping system and then inoculation tank, and then we transfer it into the cell factory. These systems are pretty cheap because of beer industry and the cell factory that we have designed. Each module would be costing like 2.7. That is like some market research I did after designing 3D models and asking for the price. So overall, the price is pretty low. As I was talking about, if you would, Yanni, go to this slide where I talk about FibDex. Yeah. Okay, and not in the forward, but anyways, for example, the cost of, you can imagine cost of cutting birch trees, processing them, separating lignin, lignocellulose, hemicellulose, chemical processing and mechanical processing. And then once you have pulp and then you process it through chemical or mechanical methods into nanocellulose to produce FibDex, that is very expensive, energy intensive and polluting. So what we are doing is like, we are just taking the food waste, feeding it to the enzymes and feeding it to the microbes, and voila, we have our product.
Thank you. Let's go ahead to Marco so that he have time to ask his question.
Yeah, for me, this also sounds like too good to be true. But what about the IP protection side?
Yeah, so during the research, we figured that getting a patent is pretty expensive at the beginning. So what we want to protect is the genetically modified microorganism and the cell factory design. That what we want to do in the beginning is like, we want to go for non-disclosure agreements with the employees and like partners in the beginning, because IPs would be too expensive. But if we do get the money, then of course we want to take the patents for the product.
I think it would be, if I have understood it correctly, it would be a key thing to protect the IP, because if you can do this cheaper and better than in anyone else, it's kind of a key to protect yourself. And then, if I understood correctly, you said that you understand the process to make this on an industrial scale. Is it so?
Very short answer. The time is up.
Yes, that's what we worked on. Yeah.
Yes, excellent. So next to present is Lucent Mind. Lucent Mind takes a novel approach to bettering your mental well-being. Their platform provides you personalized, actionable insight that you can take on the basis of 2 scores they calculate: your short-term and long-term mental reserve and strain. By taking up their proposed actions, they motivate you to balance these scores by doing the things that work for you. So now go ahead, Lucent Mind.
Yeah, if Yanni could, great. Hello, everyone. Welcome to Lucent Mind's presentation. Next, please. So our team is made up of 5 members with a diverse and complementary skill set across computer science, biomedical science, design, and business, which is our strength, we believe. Next, please. So the problem we're trying to solve is this. It's very difficult to improve mental well-being because we cannot measure progress in an effective way or see which solutions are actually proven to work. And the result is a lack of motivation, a lack of positive habit formation, and therefore fluctuations in well-being. This also strains the medical system because it takes up a lot of primary care physician time. Next, please. Our solution is to provide a tailored program to increase mental well-being that fits one's needs, goals, and dedication. This empowers the individual to make simple and retainable changes to the lifestyle. Next, please. Why is this important? On the macro level, Burnout is suggested to cost the global medical systems over 150 billion euros. So preventing these events would allow for resource allocation to be optimized. And then on the micro scale is the individual person's focused. Everyone needs to have the tools to improve themselves, and it shouldn't cost hundreds of euros like some other solutions. And how are we going to do this? We will leverage existing technologies that correlate electrodermal activity with heart rate variability, from which accurate cortisol levels are deduced. And this is used to establish a long-term trend line for one's stress levels. Estimation of cortisol is so key for us as measurements because research strongly suggests that cortisol is a proxy for long-term overactivation of the nervous system. Next, please. And the benefits we provide are that based on these measurements, we calculate a strain and reserve score for the user continuously over time, with the average getting constantly updated over time as well. And then personalized suggestions called actionable insights are given, and these depend on the relative balance of strain and reserve at a particular moment. So for example, higher or low intensity exercise. And we believe these insights set us apart from other competitors because we are untangling the overload of data and actually making inferences and giving actionable suggestions, not more abstract ones. Next, please. So far we have already started doing some initial user tests and spoken to relevant shareholders to validate our concept, like psychologists and consultants, but we plan to do some more user tests and also to start building our first MVP, which will be using existing electrodermal activity and heart rate variability technologies on around 50 initial subjects, and start building the strain reserve scores and also to test the actionable suggestions. Thank you.
Thank you for this interesting pitch. Pinja, would you like to comment first?
Yeah, thank you for the interesting pitch. I have multiple questions, but maybe to prioritize, like what is your target group? Is it like everyone, or is it specific people? If I'm looking at the sketch you have, that made me wonder who are you targeting?
For the question. I think we have multiple target groups, but let's first of all start with our main customer segment, which are young adults that are suffering from social pressure and also a lot of pressure during their work. So that was our first customer segment, which we want to focus on. I hope that answers the question.
Yeah, and another question about, if I understood correctly, you're collecting these data to wearables. So are those going to be somehow significantly cheaper than, for example, Aura?
Aura is also a wearable. So we're not going to produce our own wearable. We're leveraging the data from wearables. Okay. And therefore, we also make it way more approachable to people, that it doesn't matter which phone you use or which wearable you use. If we can use heart rate variability and electrodermal skin response, then we can calculate these cortisol levels.
Okay, good. Thank you.
Thank you.
Thank you. And next, Marko.
Okay, thanks. Very interesting product. Is there a regulatory path for this product? So are you do you need a kind of a medical device status for this?
That's a very good question, Marco. No, we're really focusing on the well-being market. We want to give people the tools for themselves to get effective insights in how to improve their mental well-being. So we will not be a medical device. We will be supporting our users.
Yeah, so
yeah.
Either for any sorts of mental ailments.
Okay, and you're gonna sell this directly to the young adults that you mentioned.
Yeah, so we have two main approaches in this way: business to consumers, so directly to consumers. We see a lot of apps out there that also sell on a subscription basis to users. On yearly or monthly basis. And then our other target is going to be business to business. We see a ever-growing need for improving the well-being of employees. So that can also be a very good source of revenue.
Yeah, basically that would have been my next question. So have you planned any that you could partner up with local, let's say Mehiläinen, for example, to integrate this to their product?
To be honest, we didn't plan that yet, but we're clearly thinking about partnering up with companies. Also checking if we can enroll an MVP there.
Yeah, also Mehiläinen, now that you mention it, is a very good potential company to partner with. I have someone that I research with who works at Mehiläinen, and I do hear a lot about difficulties day to day, even at the sort of front of house reception level, to be interacting with patients constantly, and that it can be exhausting. So this kind of thing might be of help.
Okay, thanks.
Virpi, go ahead.
Yes, absolutely. So thank you. Very, very interesting. And I go back to the basics more or less. So can you walk me through the cortisol level estimate, and how do you actually measure that? Or did I get it completely wrong? What is the kind of the basis of the reserve and strain measurements? You mentioned cortisol, but explain it to me one more time.
Yeah. Okay. Yeah, the reserve and strain are calculated by more than cortisol. So the reserve level will be also based on your sleep, for example, how well you rested, how much challenge you can take on the day. And your strain will be calculated by cortisol, where we count up the most stressful moments during the day, and that leads to a higher strain level.
How do you measure the cortisol? What's the measuring?
There are algorithms out there that are already focusing on this, that combine HRV and so heart rate variability and electrodermal response. They correlated this with cortisol, and this way they can have a very high accuracy in predicting your cortisol without actually measuring it.
Yeah, because cortisol is at different sort of segments of the day, right? And so skin response, electrical skin response, and also heart rate variability seems to move along with those kind of peaks and troughs to varying degrees. That's what's good.
Okay, so that measurement part is in a way already validated, and it's not kind of developed by you guys. Okay, that makes a lot of sense.
Our strength is the more detailed inferences we make from these measurements, which is sort of the next step that doesn't seem to be taken by a lot of wearables or other kind of competitive companies that focus on mental health improvement. It's more giving data and measurements and stopping there without
taking the bridge.
Yeah.
It's also recommending what works for the person.
Okay, excellent. Thank you so much.
Thank you.
And lastly, Johannes.
Yeah, I might have a question, but first I have a comment that you had quite a wide customer segment that you were presenting there, but actually your customer segment would be just people who already have wearables, and that would of course narrow it down quite a lot. But even at that, if you different wearables have quite different data, even though they might have the same purpose. So let's say these wrist-based heart rate trackers, they all have different kinds of data from the same, or they measure the same thing but come up with different data, and that's a real difficulty here. And we were just discussing that you would have these different kind of measurements, but are the wearables that already exist, do they actually produce these data that you need? And would the customer actually have to have more than one wearable to actually produce enough data to be of any help in let's say assessing the cortisol levels?
Yeah, that's a very good question, Johannes. And yeah, we've been thinking about it for sure. To start off, there's like 33% of the world population that have wearables right now at the moment. And actually all the wearables since the start that were measuring biomarkers were measuring HRV, so heart rate variability. And with HRV, we can already correlate that with cortisol. But if we want to improve our accuracy, we can use the latest sensors in some smartwatches that are having this electrodermal activity. So in that way, we can only improve our accuracy of the measurements. Does that answer your question?
Yeah, sure.
So
Yeah, it's. I have a lot of questions about this, but I don't think we have time to go through all of them.
We have 1 more minute if somebody has something to ask.
Okay, we're just going to say 33% of European citizens have a wearable.
Sorry, my fault.
So why is not Oura doing this or someone else?
That's of course a very good question. We see a lot more companies moving into the space, but actually this bridge between the actions and visualizing data, that's really important. And that's also where our novelty comes in. The companies on one side that are measuring and producing the data that show the data, but then the actionable part where they suggest and create this kind of weekly planning to really make a change in your lifestyle, that's not there yet. And we also don't see the intention yet from the companies that are doing the analysis. Thank you for the question, Mark.
Thank you for good questions and answers. So we will move next to Emanate. So Emanate's mission is to improve tools for cancer research and cancer drug discovery. And Emanate is developing a Microscope Add-On device to overcome the repeatability issues with the goal of enabling wide adaptability of 3D cell cultures. Go ahead, Emanate.
Hi everyone, I am Sven from Emanate, and we are improving tools for cancer research, cancer drug discovery, and cancer diagnostics. When looking at the process of cancer drug development, we see that clinical trials have a failure rate of more than 90%, which results in extremely high development costs. One of the main reasons for this is that the preclinical research disease models are failing to mimic some of the human conditions. You should click. Specifically, the mechanical properties of the 3D microenvironment in which cells are embedded inside the human body. 3D cell cultures can mimic those human conditions, but they currently lack repeatability. What do I mean with repeatability? Well, if you culture multiple batches of the same culture, some of the batches will fail to mimic the desired human conditions, making these very unattractive to use for researchers. For this, we have a solution, our Microscope Add-On, which has a hardware component and a software component. It is compatible with all the standard use microscopes in cancer research facilities. And basically what it does, it can measure if a batch is mimicking the desired human conditions. If it's not doing this, we can just simply eliminate the batch from the experiment. To use our device or add-on, we developed a method to co-culture biocompatible and magnetic probes inside the 3D disease model. And what our add-on does is generate a magnetic field, which will displace those magnetic probes. And the displacement, we can translate this into the mechanical properties of that batch. We looked at the competition based on the following 2 technical criteria, and we identified the following 4 competing technologies offered by the following manufacturers. And we also really see that we have a competitive edge in the market that can really enable the use of 3D cell culture disease models. Okay. So the total addressable market today is 1.15 billion euros, but we are now really focused on developing features for cancer research and cancer drug discovery applications. We will focus first in Europe and US, where there is a market of 175 million euros. So where are we today? We have an MVP, we have support from Business Finland, and we have already a peer-reviewed publication with the technology. We are currently finalizing our PCT application, and these are some of the next steps that will enable us to have a successful spin-off next year in Q4. We're going to enter the market with a non-medical device for cancer research and cancer drug discovery purposes, initially through direct sales of hardware and software. The software would be sold based on a subscription-based fee, so we would retain our customers. We're going to scale through distributors, first in Europe and then in USA, and eventually also globally. Next, we will grow by entering the cancer diagnostic market, which will increase our revenue streams by also generating income per fee of a fee per diagnosed patient and licensing out the technology.
3 minutes is up.
Okay.
Thank you, Emanate, for this insightful pitch. So this time we'll start with Marko with comments.
Thanks. Sounds like very interesting product. Of course, it was a bit way of my expertise, but did I understand correctly that it works only in the 3D cell model?
Yeah.
So how used is that currently? So is it kind of a widely used already?
Yeah, you will please do.
Right. So we've seen already more than 10 years ago that 2D cell cultures do not really, what is the biological standard? They do not mimic the biology in for the cells in the real, inside the real tissue so well. For example, for many diseases, particularly cancer, the results are quite different in the 2D cultures. So cancer research uses these 3D cell cultures, and much of the modern biology research uses. Also, this is usable for other than that. So let's say these so-called organoids of cancer and other diseases.
Yeah, okay. Actually my question, yeah, thanks. But the idea was how big market is it currently? So is the 3D model kind of the use model nowadays? So this kind of fits to all cases, or is there still a kind of a 90% of things done in a wrong model in your perspective?
Yeah, today we see, what we see today is that mainly for example, for drug discovery, what is commonly used are 2D cell cultures and animal disease models. And the reason why 3D cell cultures are not yet widely adopted in preclinical research is because, for example, they lack repeatability. So if you have an experiment with multiple batches, but each and every batch is slightly different from each other, you're kind of comparing apples and pears in drug diagnostics and in drug discovery. But what 3D cell cultures do have an advantage compared to 2D cell cultures and animal disease models is that they can mimic some of these conditions, which the other two fail to do so. And it is clear that those other two are really failing that, because if you look at clinical trial success rate, they're less than 10% today.
Mm-hmm.
So there is really a need for better preclinical disease models. We have a tool that can enable the use of these 3D cell culture disease models.
Now I understand better. Thanks.
Virpi, go ahead.
Yes, thank you. So yeah, you mentioned that the initial market would be in cancer research, and of course it's a huge kind of and very diverse market segment. So where would you start actually in the beginning? What would be kind of those sectors in the cancer research area that would benefit the most from your solution?
We are expert at breast cancer, of the two most important subtypes in our project, and then the solid tumor cancers, which are particularly affected by the tissue around it. So many of those, for example, ovarian, prostate, so on.
Do you have an estimate of the size of that market, that particular segment of the cancer research market?
Sven?
Yeah, well, today we see, if we see at the competing technologies, we see that the total market is 320 million euros on an annual basis for the devices they sell. But what we really like to do is initially start there, because then we can, offer the solution as a non-medical device. But we see also really potential as that. Well, basically what we're doing is measuring mechanobiological properties. And these could also be potential biomarkers when you use them with spheroids and organoids. And spheroids and organoids are going to be more and more used in diagnosing patients. Yeah. So the big picture would really be if we could incorporate organoids with our technology And initially, what we did with the market estimation today is based on colon, lung cancer, breast cancer, pancreatic cancer, and prostate cancer.
Okay.
As we also see that organoids are developed for diagnostic purposes for those cancers today.
Indeed.
I hope that answers the question.
Yes, it does. Thank you.
Thank you. Johannes, would you like to go next?
Yeah, sure. I still have a question that I maybe I'm too stupid, but I didn't understand. Is it you have the hardware there somewhere and of course software, but is the product is the like the solution that you are offering, is it a combination or could these be separated?
It's a combination. So the example I showed, one of the features we are developing now is to improve the repeatability issue. But you could also use it for other features where you can, for example, measure certain mechanism of actions by adding a drug in the culture and see how that is changing the structural environment. So that's a different feature. It's the same hardware, but a different feature software-wise, let's say. So we would sell the hardware as a one-off, and then have like different features in the software, which would be subscription-based fee. Then that's the idea we have at the moment, at least.
Yeah, that's interesting. I have one other question about the hardware. It seemed in the picture that you had that it's quite, or I don't know. It seems to me as a layman that it was quite like a substantial hardware. So how scalable is that? Like how much that would change the process for the CRO or whoever is doing the research that they would have to implement this into their workflows? Would it be a big change?
It is tailorable for microscopes because it's 3D printed. These stages costs very little. Also the coils can come in different sizes. So and the price is making it. It's we're not talking so much. I mean, biggest is if there's any manual labor there. So that's the biggest. But the components cost very little.
Yeah, thank you.
Lina, please go next.
Yeah, thank you. Really interesting presentation. My question is about, I remember you mentioned that you already have the MVP. So have you tested this with potential customers and what the feedback has been?
Sven.
Yeah, well, we have publications collaboration with Stanford. Also you actually used to Berg, so we have collaborations there. And this is really for us one of the next things to do actually. So we are very much also interested in what UPM is doing with their hydrogels, as they're also kind of tackling the same problem with the repeatability issue. But that is really one of the next things we should do with a commercial partner, try to see for collaborations and see if there is interest and how we should alter the device. And coming back to Johannes's question, like how is it easy to use for our potential customers and which kind of dimensions and what are the wells they want to use also with our tool. We are having our own self-made wells at the moment we are using, but if they want to use different wells, we should adjust to their needs.
Yeah.
And that's one of the next steps, which we also showed in the timeline, but maybe went a bit faster. But
okay, good. So kind of co-design is still happening.
Yes, definitely, yes.
Yeah, good.
There is still time for one more question if somebody has something to ask.
Is there a kind of a regulatory path for this product? Is it because it sounds like a kind of supportive product?
Yeah, good question. So initially not. If we focus on cancer research and cancer drug discovery, and that's the market we first want to approach, it's a non-medical device. But then if you want to use it in combination with diagnostics, it would be a class, or the whole diagnostic tool then would be a class C device according to the new IVDR. But for us, really, the idea would be is if we can first go in the market as a non-medical device and get more experience with spheroids and organoids, which are used in drug discovery and cancer research, it will really help us take a big leap if we want to reach also the diagnostic market.
Thanks.
Thank you. So let's move on to the last pitch of tonight. So next, we're going to hear from SpotMe. SpotMe is a mobile application that offers activities stimulating positive reinforcement in a community sharing the struggles of dealing with psoriasis. The app features include polls, exercises, challenges, and a unique user profile, all of which help users to keep track of their disease and promote well-being. So SpotMe, go ahead when you're ready.
Hi, do you like to go to a sauna or to a swimming pool? When was the last time you did it? Was it this autumn or maybe even yesterday? I'm affected by psoriasis, a skin disease, and the answer is quite different for me. I haven't been to a swimming pool for many years. Psoriasis is a genetic skin disease that causes red, scaly, itchy patches to appear on the skin, and there are 125 million people in the world who suffer from it. Most of us feel often anxious, we overthink, and we don't accept the disease, among others, psychological effects. The current solutions are either too old-fashioned or they are too complex. Sometimes they lack the community aspect, and some of them lack the physical and mental well-being toolkit. SpotMe meets all the criteria. Our solution SpotMe is a mobile application that offers activities that stimulate positive reinforcement in a community that shares the same struggles. Our features were user-validated when testing the prototype. The main features include a map with users located nearby so that people will be aware that they are not alone in their struggles, exercises, and challenges with which the users can start leaving their comfort zones and establish new routines. And also there are polls. Next slide, please. To learn about other people's experiences and about the disease itself, and everything is done in a gamified way. So the total addressable market of medical health apps amounts more or less to $50 billion US. And we have calculated, we predict that with our solution, we could potentially cover the market of almost $500 million. To do this, we want to focus on B2B sales, meaning that we want to first approach healthcare providers and offer them a license that can be distributed to their patients. And the license would be based on the number of users. This way, we can reach already established groups of patients in the targeted age group from 20 to 40 years old. Next, we want to contact other stakeholders, and we want to also launch the B2C sales. So currently we have finished our MVP, and within the next few months, we would like to file an EU trademark. We want to consider a medical device license and launch the app in the App Store in March. Then by 2023, we would like to expand to the US and incorporate one new skin disease in the application. By 2025, we would like to expand to Asia. This is our team, and we possess the relevant skills to build the solution in-house. Thank you so much for your attention.
Thank you, SpotMe, for wrapping up the pitching round. Virpi, would you like to start with the comments?
Yes, absolutely. I think I have kind of the classical questions all the time, but I think these are the most typical ones. So of course, you already mentioned in the past the regulation of the device status, but could you elaborate a bit on that in what class you are and what kind of work it requires for you to have an authorization, or did I get it completely wrong?
No, you got it right. So first, of course, is the trademark. And first, we want to have a trademark on our name. And later on, if we gather some more funding, then we would also like to have a trademark on our logo. And then we want to consider a medical device license. And this would be the class 1 medical device license, because this opens up new possibilities for us. For example, the doctors could officially prescribe the app to their patients. So this way we could partner up with more psychologists, dermatologists, and so on and so forth. But this is, like we have to think about the funding, because the money that we will need for it is quite large. So we have to gather first funding. Yes.
Fully understand that. A little bit of follow-up. Are you only considering the European regulation, or are you looking also to the FDA side?
So currently only the EU regulations, because this is going to be our first step with the EU trademark. But later on, as we want to expand to US, then we will also file a trademark in the US, and so on and so forth.
Okay, thank you.
Thank you. Johannes, go next.
Yeah, thanks. I have a question about the solution itself. That I didn't see that. Does this actually treat the condition of psoriasis, or is it about offering support to people suffering from psoriasis?
That's a very good question. And it's kind of yes and no. We don't treat the disease by recommending, for example, what kind of cream you should use or what kind of medication you should take. But we do it, we want to improve the quality of lives. So when people have a flare-up, for example, they can use the app, they can track it by adding some pictures. They can also track it by, for example, adding products or experimenting even on themselves. And then they would know which product, which kind of food causes the flare-up to appear. So there are these exercises challenges to treat the flare-up, but they are not curing it.
Yeah, that's something that I'm thinking about. That it's of course doesn't mean that this app would be, or the solution would be beneficial. But if I'm thinking about the business potential, that would probably, at least in Finland, it would exclude all of the healthcare providers, as they have they have a really strict budgetary restrictions, and they have to have some sort of a cost to clinical effect calculation there. And have you thought about if this would actually be more applicable to be sold or offered as directly to consumers?
So this is, again, a very good point, because we didn't start yet talking to the B2B partners. So we will figure it out on the way. And this is the first group that we came up with, because we believe that they have the right funding. And then the app could be a cool thing for the patients, so that they could offer them more. And then together we can develop some features. For example, maybe they would like to have a mentor on board in the app. So that's why we prioritize this group, but only when we will start talking to them, we will know if this was the right path to follow or not. And definitely when you said the comment, like, we have to consider many things, but there are also different countries. So maybe in Finland, a better stakeholder would be a foundation. But then on the other hand, the foundations don't have too much resources. With B2C sales, it's possible, but we saw that, for example, our competitors, the ones that are more successful, they use B2B sales. And in the B2C sales, it's a little bit tricky to promote the idea, because of course there are Facebook groups that we can promote it with. But for example, a social media campaign wouldn't be so effective, because we can't track the right people who have psoriasis. But this is also doable, and we are already talking to one influencer who is willing to help us with it. And then we want to onboard more influencers to do the challenges together and promote it to other people.
Yeah, thanks.
You're welcome.
Lina, please go ahead.
Yeah, thank you for a really great pitch. I like the rhythm and visuals and everything. It's really easy to follow. I think I was thinking a lot the same things that Johannes mentioned, but so you haven't reached out to any healthcare professionals when designing this, or have you considered they having some kind of role within the app?
So when it comes to these B2B partners, we tried to contact 1 or 2 associations, but we didn't get any response. And we wanted to first develop our MVP to show them what we are building, to show them that we are already doing something, that the solution is here, and then to tweak it and adjust it faster based on their needs. But we want to onboard in the near future also dermatologists, clinicians, because only when we will start testing the app, when we have the MVP, the beta version, we will see if the exercises are really effective, if they are meaningful, if people are establishing new routines. And based on it, we will need some extra help, and then we can tweak it. But with the partners, maybe already somebody there would offer us some help.
Yeah, I think it's definitely a good idea to have some like real dermatologists within this, because having, even if this changed the behavior somehow, how could the dermatologist at least know about it? How could the person share the data somehow with their treating dermatologist, for example, and would that affect the behavioral change even more? So that's what I'm interested in, the kind of co-design process with the dermatologists and specialists.
Yes, yes, yeah, definitely. We have to test it out, and then I can let you know, Pinia.
Yeah, good. Thanks.
And lastly, Marco.
Thanks. Hey, I'm also struggling to understand how this would be kind of sold as a medical device. But then coming back to the actual market, so if we assume that there would be, let's say, 100,000 people suffering from psoriasis, how many would you think that would use the product?
Well, if there are 125 million people who have psoriasis, then let's say 80% are in the right age group. I mean, not let's say, but we Googled it, that it's 80%. So then we end up with 100 million. And then it's hard to assume, it's hard to calculate it exactly, but our rough assumption is that maybe 50 million people would like to use our app because they feel the need of mental and physical treatment, well, a toolkit for it. So we think it's more or less this number.
Okay, it's a very high number still. Okay, but then how many would be willing to pay for it from the 50?
Mm-hmm. Again, we have to test it out, but with the B2B sales model, we want to learn if these organizations would be willing to pay for us, pay for the application, and then how much, and then they would kind of do the sales for us. So this would make the whole process faster.
And then it would still boil down how long would they be using it. So, but I'm just trying to figure out the market size. But okay, it's large, but all in all, in many cases that I've seen, the actual payable customers is still quite small amount. But anyway, so you explained how you came up with psoriasis, but this kind of an app to collect the people, to gather some intel and connect them would kind of work to almost anything. Is it so? In a positive sense, for example, golf players or cancer patients in a negative sense? And
definitely, yeah.
Yeah, and then my thinking goes further. So there are already Facebook groups, WhatsApp groups to kind of gather the people. So how do you kind of compete with them? So kind of an existing challenge medias of taking people together.
Yes, I wouldn't maybe call it as competition, because even though Facebook groups are there, they aren't the right tool for people with psoriasis. And for example, I am in many of such groups and many of my friends are. And every time we talk about them, they are very annoying because always people ask the same questions, or they always put some pictures there which aren't that nice. They are pretty gross, and they are asking, oh, is this psoriasis? Oh, can I use this medicine? Did it help you? But the thing with medicine is that every person is different with psoriasis, and different things work for us, different food we can eat or we have to avoid. So there are many downsides with Facebook groups. But this can actually help us to promote our app and so on.
Okay, thanks. Interesting product.
Thank you so much for your question.
Thank you for the questions and answers. The time is up now, and that was the last pitch we're going to hear tonight. So for now, I'd like to thank all the teams and judges at this point. And now it's time to take a much needed break. And in the meanwhile, the judges will go through all the teams' pitches, and it will be definitely a difficult choice. So we'll be back at 8:15. So see you all very soon. Floor to judges. So do you have any general comments about the decisions?
So maybe I can start. The microphone is already open with me. So first of all, thank you, everybody. It was a pleasure to listen to 6 very different pitches and different ideas. And I think all of you had an idea of what are you actually solving and why. That came quite clear. Of course, we understand that you are in the beginning of your path, so there's always things to improve. But I think everybody has a clear kind of drive and kind of the everybody's targeting to do something big actually, and all these ideas or these to be companies have something in it that can be kind of built further. So congratulations on that.
I could continue. I always say that the 3-minute speech it's a way too short, and it seemed that way at this time as well. But as a tip, I would kind of we usually list the kind of things that needs to be in the pitch presentation. However, still as the time is so short, you should still focus on the main items. And if there are kind of a overall people like me not understanding the substance, you still at some point you still need to explain it to kind of a layman like me. So that is also something that you need to focus on when you know that the thing is very high science. So that's a tip for the future.
Yeah, I could continue, but I think Virpi already mentioned the main points, that these ideas or pitches were very different, and it made our work a bit more difficult, because they are not kind of they are solving very different issues. But I still like to thank you everyone for the pitches, and I actually got a few ideas on what Citra could work on next.
So I was there with the judges the whole time, and we went through every team and how like what were the pluses and minuses of every presentation, and I think that everyone should still be very proud of what they did. So next up, we will pronounce all the winners from the third one to second and then the first one. So first I will announce the third team of tonight, and then the teams can give short comments of their feelings, and then judges will tell some comments like why this team. So are you ready? So the third team of tonight is food waste to bandage. Congratulations.
Thank you.
So how do you feel?
Well, I wasn't expecting to be any place, because we are just in so start of our project, and it's not because I believe that we have so much work to do on our team. So I wasn't like expecting, but yeah, thank you. I mean, I hope we can make it into a reality and make a small change, a small dent in the way things are done. Thank you.
Thank you. So what did you judges think when you decided that this is the third team of tonight?
I can start with the reasons why, since Sunil said that they are at the start of their journey, and yeah, we did notice that, but I think this idea has maybe the biggest market potential in a way, or at least the easiest path to market if everything is solved, and that's one of the main reasons why we chose it as the third one. And I think Marco can expand a bit on the business models, that what we thought that you could work on.
Yeah, so at least I found the kind of idea very simple and thus interesting from an investor point of view. And the business models, as you said, you're early on your journey, but that is something that you could think about at this point already. So it highlights the IP protection, but you could be, for example, selling the actual substance, or that you could license the production facilities and sell them. So there are many ways, but all in all, the idea is very interesting.
Thank you.
So, are you ready to hear who's the second team of tonight? So, we had these discussions and it was very hard decision on who's the third, who's the second, and who's the first one. But the second team of Terkko Health X is Emanate. How are you feeling, Emanate?
Thank you. Yeah, good. Thank you. It was really nice to pitch also in front of a real external jury, let's say, to get real questions and feedback. And yeah, we were also in the beginning of the journey to pitch more and so on and get things more straight. So thank you for the good questions and the feedback. And it was really nice to join this program also. We learned a lot and it was good fun also at the same time. Kiitos.
Happy to hear that. So what did the judges think?
Yes, mentioned it was a difficult decisions. There were so many good teams, but for the Emanate, we kind of liked a lot about the timing in that sense, because these 3D cell culture models, both in research and drug discovery and in diagnostic, they are coming, and there are a lot of efforts put on the field to kind of have less animal experimentation and use more of these in vitro models. So they are in the perfect kind of timing in that sense. And of course, their business model and everything is in the beginning and it needs to be kind of iterated most likely more than once. But I think they have the core concept and the timing, and those are really interesting, and they have a good chance to build something on this.
Thank you.
Thank you for your comments. So, are you ready to hear who's the winner of whole Terkko Health X 2021? It has been a long night and even longer program of 6 weeks, and now we are here. So I will announce the winner of tonight. So the winner is Biomedical Spectroscopy Lab.
Thanks.
Congratulations.
Thank you. Wow, this is I think it's really it's surprising because we've come a very long way. I think when we joined the program, it was basically our first time of, at least we've tried once, I think maybe 2 years ago, but we didn't really go too far. But I think this is a really interesting program, and we gained a lot, right from things about regulation to pitching and all different kind of things. And I think it's been a very, very wonderful journey. So we really hope to continue this path and get things done very quickly. So thank you very much, and thanks to all the judges.
So final comments from the judges.
Do I go, or is,
you start, Virpi.
I can start. Okay. So for us, it was kind of one main thing was that your problem and solution are in good balance. So you have identified a real problem that isn't like we are curing cancer. So it's like everything included. You have a specific problem which has a really specific clinical need, and you have a solution that fits that problem. And on the other side, you have in your team those kind of people, and I saw in the team slide that you have in the background people who can actually contribute a lot on this, and you have been already testing it and going through different phases with the end users, and this kind of like having feedback from multiple sources. So I think those were one of the main reasons that you were chosen to be the winner of this evening.
Thank you.
I could give a quick comment. You kind of improved your pitching until the Q&A session. So you were a bit quick on your pitching, but once you landed to the Q&A session, you improved a lot. So I think that is something that you could take in. So try to be a bit slower.
Slower. Yeah. Thank you.
I'd like to also congratulate all our teams. You did an amazing job with your pitches, and you should be very proud of yourself. especially after seeing your development from the very beginning through the opening weekend to this day. I can only say that you all have gone far. And of course, I'd like to congratulate top 3 team again, especially the winner, Biomedical Spectroscopy Lab. This is a very great opportunity and a great moment for you, so please embrace it. And next, I'd like to thank all our judges one more time. Thank you for being here tonight. It has been a pleasure to follow your insightful discussion with the teams, and also while we were wondering who's going to be the winner of tonight. Your enthusiasm towards new innovations that the teams have presented has shown. Thank you for taking your time to be here. And what more? Now that we are nearing the end of the showcase and the whole program, I also have a few things to announce. Unfortunately, we had to stop the live stream due to technical difficulties to allow us to continue the show. Luckily though, that didn't stop us from recording the show, and we will be publishing the record in our channels. So expect to see that in the following weeks. We're gonna give you more ideas about this whenever we have the materials ready. And additionally, even though this is the last official day of Terkko Health X, all participating teams will still hear from us next week. We will inform you about the prizes and provide you some feedback about tonight. And hopefully this all will help you to further develop your ideas even after the whole program. You also have a chance to book a final feedback session with me and Jani. And if you like to talk about your feelings after the program or what are your next steps after Terkko Health X, we're going to be here for you. But I've been speaking a lot tonight, and this was all from me at this point. So thank you one last time, and have a great rest of the evening from my part.
Thank you, Lina, and thank you for all the participants and for all the organizers and judges from my part as well. It's been a pleasure to host this evening today. And I hope to see you all physically here in Terkko once this crazy situation gets better soon. And I wish you all have a very nice beginning of the December and waiting for the Christmas season. So thank you for this evening. It's been magical.